Hi, everyone. My name is Zachary Cartwright. I'm a food scientist and an isotherm application specialist at Meter Group. Today, I'm excited to talk to you about two of my favorite things, water activity as well as isotherms. I'm joined today by my colleague, Mary Galloway, and I'll let her say hi.
Hello, my name is Mary Galloway. I also work for Meter Group. I'm an application scientist here. I've been doing that for about 10 years. And I'm also excited to give this presentation about water activity and its role in animal feed. So if it's all right, we'll just begin. All right, I'd like to begin with water activity and by introducing what that is and a little bit of background. So back in 2015, National Geographic wrote an article about archaeologists that had been excavating in the pyramids. And one of the things that was really remarkable is they found all these pots of honey. And these pots were over 3,000 years old. And the amazing thing about that is that the honey was still edible. So even after that amount of time, you still could eat that honey without any harm. Honey is amazing. One of its characteristics is the fact that it actually has a low water activity. And we're going to be talking about that specifically for microbial growth and how that relates with animal feed and other applications. So water activity is useful for many things. Since that time, the Egyptians used it a lot in various ways. We've been able to kind of build on that. So one of the ways we can use water activity is for product formulation. I've got a picture here of some breakfast cereal with some nice tender fruit and some crispy flakes. And the fact that we can have these completely different textures of product in one thing is because of water activity. Also for looking at chemical and physical stability of raw ingredients or even final products, lipid oxidation or vitamin degradation, water activity is a key for maintaining that stability. We can use it for limiting moisture migration. If we can keep water activities the same, then we won't have moisture migration between them, and we will discuss that further. Also for assessing packaging related to changes in water activity. You can set product specifications in your processing plants to maintain the quality you're looking for and your customers are looking for. And lastly, it's key for preventing microbial growth. So for water activity, there are three main principles that I want to make sure you understand. Water activity is actually a thermodynamic property, and that means it's based on energy. And energy is a driving force. So whenever there's things that happen in the world, physics is responsible, energy is going to be the driving force for that. And because water activity is based on energy, it also is a driving force. That also means that if there's a higher activity, that means there's more energy and the water can do more. And specifically, it can do more in terms of microbial growth, moisture migration, and chemical and physical reactions. And lastly, differences in water activity will dictate how moisture will move. So same as with thermodynamics, if you have a high energy level, it wants to go to a low energy level because that's more stable. The same is going to happen for water activity. So if you have a high water activity introduced to a low water activity product, maybe something next to it, then you're going to get moisture migration. You're going to get the water to move from the high water activity to the low water activity. And that means it's not moisture content. That's not a driving force, but water activity is. I have a little demonstration here about honey and a cookie. So if we look at these, we can tell and look at the moisture content. It would probably be easy to see which one is going to have higher moisture content. The honey is liquid and the cookie is nice and crunchy, so we would expect that the moisture contents would be much different, and it's true. The moisture content in the honey is around 18%, and the moisture content in the cookie is only 5%. Or the water activity. So now we're talking about energy level, not amount of water here. You may be surprised to see that the water activity for both of these are exactly the same. So if we were to measure water activity in the honey, even though it has a lot more moisture, we would see that the energy level is lower, meaning that it's more bound, which we will talk about in the future. So you can have different products with drastically different moisture contents, but exactly the same moisture, exactly the same water activity, and that's really key. So if we submerge the cookie in honey for a week, what do you think would happen? Well, because water activity is what's going to be the driving force and they're exactly the same, nothing will happen. So if I put this cookie in the honey for a week and I pull it out, it'll still be crispy and crunchy. It won't change at all.
Next, we'll talk about water activity and microbial growth. There's a lot of detail here and a lot of things that we can go into, but there's just a couple driving principles that I wanted to cover today. So anytime a microorganism is in an environment, it's going to use the surrounding water, and a couple different scenarios can happen. And the first one that we're going to look at is if the microorganism is surrounded by a water activity that's lower than its interior. So it might look like this, that the water activity inside that microbe might be 0.95, and the surrounding water activity might be 0.9. And in this case, the microorganism is going to undergo osmotic stress, and water is going to need to move from the inside of that microbe out so that it, and because of this, it's going to start to lose turgor pressure. So to deal with this situation, what the microorganism can do to compensate is try to lower its internal water activity. And there's really two different methods that this can be done. So here to the right of your screen, you'll see that the microorganism is starting to incorporate things like amino acids or polyols or sugars. So that would be one way to lower the water activity. It can also change the makeup of its membrane in order to deal with these types of situations. So in this example, the microorganism has reached a water activity of 0.9, and it can continue to grow and it's happy. But if there's an instance where the microorganism can't match the surrounding environment's water activity, then it's going to go dormant. It might form a spore, and it's going to stop growing completely. So it doesn't mean that the microorganism has been killed, but it does mean that it can no longer grow and reproduce in this type of environment. And in fact, all microorganisms have a lower limit where they can no longer grow. And this is something that has been researched extensively. I generally show a table for bacteria showing their lower limits, but I know that molds are probably more of a problem in your industry. And so Mary helped me put this table together, just showing that the different microorganisms here on the left. And then on the right, this is the minimum water activity. So below this water activity, these microorganisms cannot grow and they cannot reproduce. Now, something to keep in mind is that water activity is just one step. This is just one control method. And Mary also found this figure for me, and I think it does a really good job of demonstrating hurdle technology and just remembering that water activity is just one of these hurdles. I know for a lot of your products, you're also considering things like pH and different additives and temperature and different things. And so there's a lot of different ways that we can put these hurdles together, and water activity is just one critical step to this process. So just keep that in mind as you're thinking about microorganisms and thinking about the hurdle technology that you may be using to prevent microbial growth.
All right, so now the next question is, how do we control water activity? So water activity is affected by chemical and physical bonding. And what that means is that when the water is bound, then its energy is reduced because it's kind of locked up. I have an example here of sodium chloride, some salt, that is a really great bonder to water. So is sugar, is also another one. Another thing that influences water is the amount. So if there is less water available, then there's less water to do things, right? So that makes complete good sense. And the last thing that water activity is affected by is temperature. And this is going to be important because as temperature increases, water activity increases. And if you're talking about products that maybe get shipped around the world or stored in warehouses or in that don't have climate control, then that is going to really affect the water activity of your product because it's going to go up. So when the temperature increases, then the water activity increases. And if you can think about that in context of like microbial growth, now you have issues where maybe before it was a low enough water activity that we didn't have any microbial growth, but now we've put it in an environment where that water activity increases and now it can grow. So here are some ways that we can control water activity. You can actually dehydrate the product more. That relates to the amount of water. So if we dehydrated or baked, let's say it's a kibble or a feed, something like that, we could just simply dry it harder. You could dry it down more, and then that would reduce the water activity. Another thing that we can do is have edible films or coatings. And so this kind of prevents the moisture from being able to travel. Essentially, we're keeping it from moving. And so you can put a coating. I know in pet kibble, they'll put like a fat coating on the bit, and that will keep the oil, will keep the moisture in and not let it move. The last thing we can do is actually some additives. So salt, I mentioned earlier, these are all good, what we call humectants, which means that they're going to bind with the water. So you maintain your moisture content, but now you're lowering your water activity because you're binding with the water. So here's some examples that we generally use in the food industry: salt, sugar, glycols, amino acids, polymers, and acids, and some are better than others. So but this is just a good general list for some direction on some additives that could be used.
All right, next we will be talking about moisture sorption isotherms and just what they are and what they can be used for. So this is a figure that I like to show to kind of explain what an isotherm is. So on the x-axis here, you'll see water activity. Again, this is a measure of water energy that ranges from 0 to 1. And then along your y-axis, you have percent moisture content. So every time you take a water activity measurement, this is a corresponding moisture content value. And the reason that this is helpful is because water activity is a very high precision, high accuracy measurement, and we can use this to relate it back to moisture content. But this is just one small piece of a much larger puzzle that we call a moisture sorption isotherm. So the isotherm is the complete relationship between water activity and moisture content. And the reason that this is helpful is because as you move up and down this isotherm, it can affect things like microbial growth, it can affect reaction rates, as well as physical properties or transition points for the products that we're looking at. So when we use this in the food industry, we generally talk about this being a balance between the safety and the quality of the product, as well as the yield and revenue. And we'll be looking at a calculation later that relates back to yield and revenue. So isotherms, I like to call them a complete moisture map because they tell us everything that we need to know about the water in that product or in that sample. And every product that we look at, so whether it's a different ingredient or a different product, or even just a different formulation of the same product, these will generally have their own unique moisture sorption isotherm. There is some overlapping that occurs, but we don't know it unless we run a test and collect the data and see what that relationship is. Another thing to keep in mind is that these isotherms can either be adsorption or desorption. And what I mean by that is that if we're looking at the adsorption curve shown here, this means that we're looking at how water binds to that product or that sample. If we're looking at the desorption curve, then we're looking at how water is removed from that product or that sample. And there's a difference that occurs between these curves. That difference is known as hysteresis. And we won't get into a ton of detail about it here, but if that's something that you're interested in learning more about, please reach out to us after this presentation. Now, if I had to name the top 6 isotherm applications, generally this is used in R&D teams, and I tried to summarize it up into 6 different points. So the first one is maximizing moisture content for profit. So by having that moisture map, you can understand exactly how much moisture can be in that product while maintaining the safety and the quality that you're after. The second thing that isotherms are used for are avoiding any unwanted texture change. So this could be caking and clumping, loss of flowability. We also use this for snack foods to understand losing an ideal texture like crispness or so on. We can also use isotherms to calculate a shelf life. So after a 2-day test to create that isotherm, we can use that information to predict a shelf life instead of waiting weeks or months for an accelerated test or a physical test. And I have more on the next slide about that. We can also use isotherms to choose the correct packaging. So the packaging that you choose for your feeds, that's going to have a water vapor transmission rate. And we can use the isotherm to understand the water vapor transmission rate that you need in order to hit a desired shelf life. We can also use isotherms to predict environmental effects. So what I mean here is that as that feed or as your product leaves your facility, it's going to be exposed to different humidity and different temperature. And we can actually predict how the water activity of your product will change according to temperature or according to humidity. So we do have a temperature effect tool where if we create 3 isotherms for your product, then we can predict the water activity at any temperature. And I think that's one of the things that would be helpful to your industry. And then the last point here is just accelerating formulation processes. So by using isotherms, we can model new products or new formulations before they're even made, so that we can understand how the water will behave in that new product before you even make it. So from here, I just wanted to touch briefly on shelf life. Mary and I have a complete webinar on shelf life alone. So if that's something that you're interested in listening to, I believe Mary mentions it and shows the link at the end of this presentation. But for shelf life, we can look at this 2 different ways. The first way is going to take into account 3 different factors. It's going to take into account the packaging that you're using, the storage conditions where your product is sitting, as well as the sorption properties of your product. So we've developed a calculator based on Fick's law, and basically you just plug in these values and then it will tell you a shelf life based on a change in water activity over time. We can also look at shelf life based on chemical stability. So if your shelf life ends because of an active ingredient is lost or a vitamin degrades or some other thing that we can measure over time, then we have another tool that we can use called the chemical stability tool. So these types of calculations are found in our moisture analysis toolkit. This is a software that we've developed that makes it really easy to take that isotherm data and to turn it into a whole range of different solutions, including shelf life calculations.
So I do have some actual isotherms for some animal feeds that we ran in our R&D lab that I'd like to show you. So these are what we call adsorption isotherms, because I wanted to specifically look at that property for each of these. How do these absorb? Because if we're looking and we're talking about shelf life and if we have microbial growth and that kind of thing, this is where we need to be looking is how the absorption is going to change for each of the products. So on the top, this is the same style of graph that Zachary showed before with water activity along the bottom axes, and then on the left is the moisture content. The top. Thank you. The top trace there in yellowy gold is for swine feed. In green is next is chicken. And they are quite similar, but also not exactly the same, which is interesting. Then we have 2 different kind of aqua feeds. So we have aqua grower, and then the bottom one is for fingerling. So different size fish, different size feed for the aqua industry. One thing I want to point out is that you can see that they're all different. Some, like I said, the swine and the chicken are a little more even, but they still have different isotherms and different relationships with moisture content. And then what was quite surprising is that the aqua also had a completely different shape than the other feeds. So I wanted to focus on the fingerling for a moment. So I'd like to kind of zoom in and just highlight that isotherm in particular. And to call out three actually, data points that I think are interesting. So if we look just specifically in here, when we look at this little section between 0.5 and 0.6, we have a large range of water activity change, but we have a fairly small change in moisture content. And that's why water activity, it's great to have this relationship, because water activity is such a the scale is so much better when we're looking at changes than for moisture content. And so I just want to point out that we have less than 0.5% change in moisture content over this portion, but a 10% change in water activity. And that's really easy to read with a water activity meter. And in particular, I also want to highlight the purple dot that's on the far right there. That data point at 0.6232 is actually where you might notice there's an increase of moisture uptake, meaning that as the sample, the fingerling feed is exposed to higher humidities in the ambient surrounding area, and as it increases, it'll start taking up a lot more moisture after this point. So if we're just measuring moisture content, that's a pretty small area. That resolution is pretty tiny for moisture content, but in water activity, it's huge. And so that's kind of an important point of why water activity is really useful to be able to keep products in a safe and repeatable zone when we're in production.
From here, I'll be talking about the financial impacts of using isotherms and using water activity. One thing that I did want to mention on this previous slide is most moisture content methods, they're going to be plus or minus 1 to 3%, and water activity is something that we can measure down to 0.005 or 0.003 with our instruments. So that is something to keep in mind, that we can really pinpoint water activity. Moisture content is more of a guessing game, and I think that this was a really good figure to demonstrate that, Mary. Okay, moving ahead, financial impacts. There's a lot of different financial impacts that we could focus on, and because we are kind of limited on time today, I just want to focus on maximizing moisture content for profit. So this is kind of a two-step process. The first step is using an isotherm to set your guardrails. So here's an example of a product, and what we're looking at here is the isotherm, and then determining the ideal water activity range for this product. So the way that this is determined is because below this water activity, or excuse me, above this water activity represents lost safety. So this is where we might start to have issues with microbial growth. And below this water activity represents lost quality. So once that water activity range has been set, then we can use the isotherm to relate it back to moisture content. And anything less than this ideal moisture content represents lost yield and revenue. So by having this isotherm, we can identify our sweet spot for optimizing all of these things that we're interested in. The second step is reducing the variation in your production. So it may look like this. You might have an average moisture content of 9%, a wide range in moisture content, and some of your product may be going over the safety limit where you start to have issues with microbial growth. Once you start increasing your number of readings, you can not only reduce the variation, but generally you can increase your average moisture content and prevent your products from going above that safety limit. So it's a two-step process, and quickly I just wanted to point out the instruments that are used to achieve this. So the step one requires that you create isotherms for your product. At Meter Group, we have the Aqualab Vapor Sorption Analyzer. This uses a patented method called the dynamic dew point isotherm method. And this is the method that we use, and this was used when Mary showed her results to show the different feeds in a very high resolution form. So step one, create those isotherms. Step two is the measurement. So we have several different instruments to measure water activity. And I don't want to go through all of them today, but just know that we have the instrument that you would need depending on your situation, either the Aqualab 3, the 4TE, or the TDL2. So these are the instruments that we use to measure water activity. We can actually put an isotherm into these instruments so that when you measure water activity, you also get the moisture content. So this is part one of step two. And really the second part is management. So as you start to collect all of this data, we have a measurement management system that we call Scala. So Scala makes it really easy for you to view all of your measurements, who's taking them, where they were taking. You can add additional inputs or additional factors about your products that you want to collect all in one place. So it makes it really easy. Anywhere that you have a screen, I'm showing an iPad here, but this can be accessed anywhere that you have a screen so that you can understand what's going on with your production. And then if there's a problem, then you can hit it head on and you have that data in real time. So if you're interested in learning about any of these instruments or solutions after the presentation, please reach out to us. So as a quick business value example, this example is for a pet food company here in the States. And they have a huge annual production. And in the past, they had a moisture content target of just 10%. So using that isotherm, we were able to show this company that they could actually be producing at 10.4% very safely while maintaining their quality and their safety. So because this company spends a lot on their raw materials, well, first off, here's an example of what that change looks like. So going from 10% to 10.4% and reducing the variation. Now, this company is spending a lot of money on raw materials, and by replacing just a little bit of that raw material with water, their annual revenue increase was well over $1 million USD. So even a small shift in moisture content can have a huge financial impact. And I would guess that the same is true for your industry. If you're able to increase that moisture content, then it's going to have a huge impact on the annual revenue for your company. So thank you guys so much for listening. We really appreciate your time. I'm sure we're well over our 20 minutes, but we had a lot to say and a lot to share today, and I hope that you found it useful.
Yes, I wanted to make sure that people know that we have a really, really great website, metergroup.com. We have a lot of scientists that work for Meter Group and have put together what we call knowledge-based articles, webinars, application notes, all sorts of things. So here's just a little sampling of some of the things that you can find on metergroup.com. And in particular, you'll see in the blue those two lovely faces. There's Zachary and I, and our presentation for shelf life and packaging, which we did last year, I think. But there are a lot of resources. Just start searching. You'll find a lot of really great content. So I just want to leave you with that. And then lastly, if you have more specific questions that cannot be answered on our website, please reach out to us. Zachary's email is zachary.cartwright@metergroup.com. I'm just simply Mary at Meter Group. Yep, Mary at metergroup.com. Been there long enough that I don't have a last name. So, and that's it. So thank you very much. We look forward to your questions.